Assalamu alaikum. Today I'm going to make a quick revision for chapter 5 and 6, Physics Lab 1. So the quiz will cover chapter 5 and 6, which is chapter 5 uniformly accelerated motion, and for chapter 6 a projectile motion. So let's start with, so in this part I will cover chapter 5 and 6, and for the part 2 it will be a quick, or I think I will solve a previous quiz which was on 22. So let's start with chapter 5, uniformly accelerated motion. Let's start with definitions. So the uniformly accelerated motion, it is the motion of an object along a straight line with a constant acceleration. And for the free body diagram, it is a diagram that shows all forces that apply on the object. Here we have dynamic, the branch of physics that deal with objects in motion. We have kinetic energy, and we have kinematics, which was the formula of motion, and kinetics, which is Newton's second law and Newton's third law. So let's start with free body diagram. Here we have, I will write it here. So we have this inclined, and we have this object. So this object, let me draw it here. So this object applied, we have force, which is Fn, the normal force, and we have, so here I will deal with y-axis, okay, and here x-axis. So here we have here we have w sine theta, which is mg sine theta, and here we have this angle, and we have here we have wg or mg, and here we have this angle, and here for here we have, so this is mg cosine theta. Okay, so here dynamics, apply Newton's second law. So here when we write the component of y and x, so we start with y, for example, y-axis. So here we have Fn minus mg equal nothing, which is 0, because in y-axis we don't have motion, just in the x component or x-axis we have ma. So here we can say Fn equal mg, and I'm sorry for that, I'm sorry for this one. So here we have mg cosine theta equal 0, so Fn equal mg cosine theta. For the x-axis we have, here you can see mg sine, and we have, which I will write it, max. So mg sine theta equal max. So here we will notice that m will will cancel each other, and we end up with g sine theta equal ax. So ax equal g sine theta. Yeah, so so here imagine we have this graph and x-axis and y. So here in y we have x, the distance, and we have here t square, which is the time. Okay, and he asked for the slope. So basically in kinetic or kinematics we have this this formula, x naught plus v naught t plus half g t or half a t square, and always x and x naught and v naught 0. So we end up with x equal half a t square. We will notice that in this graph we have x and we have t, so let's ignore it, and we end up with so I just forget to draw the line here, the line for this graph. So so ignore x and t squared, and we end up with the slope, which is half ax. And if we want to find ax, it will be 2 times slope. And if we want to or let's say we for x-axis we end up with ax equal g sine theta, so we can replace ax with g sine theta equal 2 times the slope, and we can find the g by divided by sine, so 2 times slope over sine theta. Okay, so this for this in lab we don't need it, we just need the theory. This to find t1 and t2 and t3 and find the average, and then square it. Yeah, we didn't have anything now. Okay, so we finished chapter 5. Let us move to chapter 6, which is projectile motion. Okay, so in projectile motion, if we have like this one, and you have this object, let's say it is like a ball, so in projectile v o y or v naught y, it is 0, and for the v naught x it will be constant, because it will be like this, same magnitude, and it is constant, and v naught it will be 0. For horizontal projectile v naught 0, so we have this formula, same thing but in y-axis, and we have g. So as always, y naught 0 and v naught 0, so 0 times t 0, and we have half gt square, and we end up with y equal half gt square. For the total time of flight is independent of the initial velocity, therefore the time of flight shouldn't change as the initial speed is increased. We don't need this, we just need so let's show some points on this graph. here we just want to notice that Vox is constant because it is, it's going like this side, and for VO or V naught Y it is going here. Here we have maximum V naught Y, we have maximum, and here we have like direction in the positive direction, here negative direction. Let's see. Okay, let's see this. To study the relationship between the angle of the projectile and its range, and to find acceleration of a gravity, which is G experiment, the relationship between the angle and its range is given by this formula, which we end up with R equal V naught square times sine 2 theta over G. Okay, so R is range and V naught, it is the initial velocity, and for the angle he said that at which the projectile is launched, and G is acceleration, which is acceleration of gravity, of course, which is 9.8. So if V naught and G are constant, which for example, imagine that we have graph and we have V naught here, V naught square, and here we said and here we have G. So we have this formula, R equal V naught square times sine 2 theta over G. So if you want to find the slope, you have V naught and G. Let us make them as a constant, and we end up with slope, which is, or I'm sorry, let's imagine that we have this graph and we have here, I think I draw it, here, here, sine 2 theta and R. Okay, so and G. So let us make sine 2 theta and R as a constant. So we end up with V naught square over G, right? And that's what we find. Of course, the graph will be as a line here. Y makes that be. And he said same thing. Here the G experiment, V naught square over slope. If we have slope, V naught over square over G, and we can find the percentage error. Here we have R and we have sine 2 theta. We end up with slope equal V naught square over G. And here if he give to us sine theta, it will be like this, but it is not important, just focus on this graph. Don't have anything here. And for instant, if you so we take that this graph R sine 2 theta, it will be like this, right? And the slope will be V naught square over G. Let us say if we have here R and sine 2 theta, what it will be? Just flip the slope, or it will be like 1 over v naught square over g. It would be g over v naught square. So the slope would be g over v naught square. So we just flip the x and y axis. Yeah. So now we just finish. I would check if I have let's say any points that I didn't mention it. No, we don't have anything. Yeah, we just v naught x is constant, and everything here I will cover it for the part 2, which we will cover a previous quiz. Yeah, here sine 2 theta r, it is not normal thing, so we just take that r and sine 2 theta. Slope will be here. Slope will be what? Will be v naught square over g. Let us say he gave it to us the y, sine 2 theta, and for x r. Slope will be, this is not correct. Okay, slope will be g over v naught square. Okay, because we take r and sine 2 theta as a constant. Yeah. Okay, and this is the end of this part. Part 2 will be quick revision from previous quiz.